Good afternoon. We learn geology the morning after the earthquake program. Creative, eager to gain new knowledge. Creative, cre means creativity, active means main vision is to bring constructive thinking on various domains. Our main focus on non-textual, non-academic, non-syllabus related concepts. Every Saturday, we organize online talks on various topics, and we live streaming on Zoom. We live streaming on YouTube channel Creative GBD and Zoom platform. And we thankful to all our resource person for accepting our invitation and sharing their knowledge. Today is 70th episode of Creative. Today's topic is Noble Metals from Earth to Ornaments. To present this, we have Dr. M.B. Deepa ma'am with us today. I welcome you, ma'am, and I welcome all the creative participants for today's session. I call Srimati Pushpalata ma'am, Creative Associate, to present, to introduce today's speaker. Over to Pushpalata ma'am.
Thank you, Priya. Good afternoon, everyone. I am Pushpalata, a creative associate. Everyone, welcome to 70th episode of Creative Weekend Talk. Today's talk is on Noble Metals from Earth on Ornaments by Dr. M.R. Deepa. Let me introduce you about her. Dr. M.R. Deepa was born on 30th December 1984 in Madurai, Chitradurga district, Karnataka. She did SLC in Madurai, PUC in Hosdurga, BSc in GFGC Hosdurga, and MSc in Kuvempu University, and also got the PhD in electrochemistry from Kuvempu University in the year 2013. Here are some of the academic awards. Got cash award certificate from securing highest marks in the BSc final year physics examination held in the month of May 2006 from Kuvempu University. Secured 5th rank in BSc during 2006 from Kuvempu University. She secured first rank and gold medal in MSc during 2008 from Kuvempu University. Got merit award from Jawaharlal Nehru Memorial Fund, Tinmurti House, New Delhi. Got Inspire Fellowship Award from Government of India, Ministry of Science and Technology, Department of Science and Technology, New Delhi. Some of the research publications and paper presented includes electrochemical studies of ceftriaxone and erechrome black tea polymer film modified glassy carbon electrode, and cycle voltammetric studies of gem fibrosil at poly modified glassy carbon electrode. Simultaneous electrocatalytic determination of simvastatin and gem fibrosil at poly modified glassy carbon electrode. Presented paper on electrochemical studies of Ceflor at glassy carbon electrode, a cycle voltammetry in the National Conference on Recent Trends in Analytical Techniques. Presented paper on cycle voltammetric studies of simvastatin on glassy carbon electrode and immobilized by SDS surfactant, and life membership in Journal Electrochemical Science, Indian Institute of Science, and special talks delivered at Prasara Bharati All India Radio. As a resource person, she delivered special talks on opportunities for the youth in the field of chemistry, chemistry of cosmetics, studying basic science and its advantages. National Science Day 2020 theme is Women in Science. We welcome you, Dr. Deepa Madam, to our weekend talk.
Thank you, Pushpalata ma'am. Over to Deepa ma'am.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Good afternoon, everybody. Thank you very much, Supriyanka and team, for a nice introduction. It's a matter of great happiness for me to be here to present a topic on noble metals from earth to ornaments, organized by Creative Group. Actually, before going to the exact topic, just think everything in nature, from the mountains and the oceans to the air we breathe, the food we eat, are made up of simple substances, okay, called elements. Simple substances called elements.
Your screen is visible, ma'am.
Yes.
But open the PPT presentation.
Yeah. Is it okay now?
No, ma'am.
Back. Open PPT. Wait. Now also.
Ma'am, minimize this screen, ma'am. You will find that on screen.
Yeah.
Just minimize that.
Yeah. Yeah, minimized.
But we are not able to see your screen, ma'am.
Okay.
Yes, ma'am. Okay.
Okay. So whatever we eat, whatever we breathe, the air means made up of simple substances called elements. Without these, our life would not be there. Okay. You may have already heard of several of them, like hydrogen, oxygen, gold, iron, okay, etc. These are just 4 out of 118 elements present in the periodic table. Just like the dictionary for to search the meaning, this is the periodic table. This is the Bible of chemistry. Whatever the characteristics we have to find out means we have to see the periodic table. All the elements, 118 elements, are arranged in rows and columns. Okay. Then every element in the periodic table has its own story, from where it comes, from what it can do, and how we can use it. Okay, so let's begin a tour of noble metals from earth to ornaments. Noble metals. What is meant by noble metal? In chemistry especially, noble metals are metallic elements, resist oxidation and corrosion in moist air, even at high temperatures. Actually, these are the metals. Whatever the characteristics of metals, these two have those characteristics. Especially one special character adds to this, means these are metallic elements, resist oxidation and corrosion in moist air, even at high temperature. Oxidation means loss of electrons. Okay, it reacts with oxygen. Then what are noble examples of noble metals are 6 platinum group metals such as ruthenium, rhodium, palladium, osmium, iridium, plus silver and gold, together called noble metals. Why these named as noble metals? Someone will keep some nicknames, okay, like that. some group of elements on the periodic table of the elements have earned nicknames based on their shared characteristics. For example, group 8 elements we nicknamed as noble gases because they did not easily react with or combine with other elements, like nobility refusing to mix with other elements. In a similar way, thought of noble metals earned their nickname like noble metal by resisting attack by heat and oxygen. That's why the name as noble metal. Okay. So what are the properties similar to metals, but some special characters are there. These noble metals are siderophiles, means iron lovers. They tend to sink into the earth's core because they dissolve readily in iron either as solid solutions or in the molten state. Most siderophile elements have practically no affinity whatsoever for oxygen. Indeed, oxides of gold are thermodynamically unstable with respect to the elements. So I have already explained corrosion resistance. Okay. Then what are the uses of these noble metals? For what purpose we are using noble metals, and what is the importance of these noble metals? Means noble metals find use in coinage, means to make coins, jewelry, medicine, electronics as protective coatings, and in chemistry especially as catalysts. These noble metals are often plated over base metals like over the copper, over the other base metals to protect them and add value. Especially gold and silver are used in medicine as antimicrobial agents. Gold and silver are used in wires, contacts, and electrodes. Ruthenium and iridium are hard metals that strengthen alloys and find use in small machine parts, pen nibs, and spark plugs. Okay. So one by one, let's discuss. First, let's take gold because anyone having not interest in gold means if you tell raise your hand if anyone has not having any interest on gold means no one will rise because everyone we human beings the two Indians are crazy about gold. Okay, so not only now, actually before 18th century this chemistry was familiar with the name of alchemy. The whoever study alchemy called alchemists. Those alchemists itself, they are trying to change, they are trying to convert the base metals into gold. Okay, so we have much craze about gold. At least one earring, at least one nose pin, at least one bangle. Okay, in our lifetime we have to wear the gold. So gold in its purest form is a bright, slightly reddish yellow, dense and soft, malleable and ductile metal. Okay, it is one of the least reactive chemical elements and it is solid under standard conditions. Gold, how gold occurs in the earth? Okay, so gold occurs in free elemental form or native form as nuggets or grains in rocks, in vein and in alluvial deposits. See, this is gold present as a nuggets form. This is gold present as in the rock form, gold present in the vein form, and here in the alluvial form. What is this alluvial form? Alluvial gold deposits form over time where a river runs or has previously run through the ground which is rich in gold. The erosive power of the water removes the surrounding rock due to its comparative.
Ma'am, your screen slides are not changing, ma'am.
Oh, is it? I'm changing, but why it's not?
It is not in slideshow which is shared. It is your PPT which is shared.
Yeah. Now also.
Still the same.
Wait.
Maybe you need to share full screen.
Yeah, full screen. Now, okay.
No. Okay. It is
Yeah.
it is
Yes,
changed
ma'am.
in your PPT.
Now, okay. ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ ಈಗ?
Yes, ma'am.
Ma'am,
Gold.
Gold we are seeing, ma'am.
Yeah. Now,
Not changed, ma'am.
now okay.
Yes, ma'am. Gold. Yes, ma'am. It's
If
a
I
picture,
share
ma'am.
full screen, it's not changing. Okay. Yeah. Gold
Slideshow, you
present in,
keep in slideshow, ma'am.
if I put slideshow, it was not changing. Okay.
Yes, ma'am. Go on, ma'am.
Gold is present in the form of nuggets. Okay. Gold is in the form of rock. Gold is present in the form of vein. Here, gold is present in the form of alluvial form. Okay. So, then where the gold is exist, where are the gold resources are present? Okay, gold is usually found alone or allied with mercury or silver, but can also be found in ores such as calverite, sylvanite, nagianite, pedzite, and crenarite. World review, where the gold is present all over the world. Okay, the gold reserves are mainly located in Australia, Russia, South Africa, USA, Indonesia, Brazil, and Peru. When come to India, gold is relatively scarce metal in the world itself and a scarce commodity in India too. The domestic demand is mainly met through imports. By states, when you compare states, largest resources in terms of gold are located in Bihar 44%, followed by Rajasthan 25%, Karnataka 21%, West Bengal and Andhra Pradesh. Andhra Pradesh 3% and Jharkhand 2%. The remaining 2% resources are located in Chhattisgarh, Madhya Pradesh, Kerala, Maharashtra, and Tamil Nadu. So, although Bihar is the leading state in India as far as resources of gold ore are concerned, however, the resource estimate are at preliminary stage and falls under inferred and reconnaissance categories. In terms of metal content, Karnataka remained on top, followed by Rajasthan and Andhra Pradesh, Bihar and Jharkhand. In India, the two, especially in Karnataka, gold is presently produced from three mines, namely Hatti, Ooty, Hirabudni in Karnataka, and as byproduct from base metal sulfide deposits of Rajasthan. Okay, Hatti Gold Mines Limited (HGML) as the unique distinction of being the only producer of primary gold in the country. Karnataka is only the gold producer presently. Okay. So then comes to gold mining. Gold mining remains relevant and valuable in today's global economy for several known reasons. Given its scarcity, it is rarely found in concentrations that make extraction economically viable. In order to support a profitable mining project, gold explorers conduct geological surveys. First, geological surveys will conduct targeting concentration levels that are 1,000 times higher than normal. Then, after discovering an ore, geologists will find out, oh, ore is present, gold ore is present. Then, and engineers will engage in feasibility study to determine whether the project has economic value prior to commencement of any mining operations. Okay. So then after seeking the necessary approvals, the next phase focuses on extracting gold from other natural material. Once the gold is purified, it is smelted and pressed into gold bars to be sold in the market. Then how gold will get processed? Gold first, before modern technology, gold panning, because gold was easily existed in the form of free nuggets. Okay, so all we know gold played a central role in development of metallurgy at one time. However, there was no need for any chemical treatment, any metallurgical knowledge to recover the gold, because it occurred in nature in the native state, and in simple panning, gold panning was enough to collect the glittering particles. How? In this method, the material is mixed with water in a shallow pan, and by careful swirling, the impurities can be washed away, leaving the gold behind. But nowadays, as machinery was developed and extraction processes perfected, mining was extended to less rich deposits. First, we were conducting the highly rich deposits, but we are conducting the mining operations at less rich deposits also, because means our needs have increased. First, no, in our lifetime, we used to, oh, two bangles are enough, four bangles are enough. Now we require more design bangles. Means we are, oh, more designs, chains we want, more gold accessories we want. So less rich deposits also we are moving for mining. For low grade deposits, other methods were developed. However, with the expansion of gold mining to ores that are not on the surface has led to more complex extraction process such as pit mining or and gold cyanidation process is moved. Then how the process is started. The gold is extracted through fire assay method. First, the ore is taken for the crushing and pulverizing the sample. We are crushing the big ore samples, then small pieces converted into small powder by using pulverizer or vibratory cup mill or ball mill. Okay, then ball milled sample is weighed and mixed with a fluxing agent. The flux assists in melting, helps to fuse the sample at 900 to 1000 degrees Celsius in some ceramic holders and promotes the separation of the gangue material from the precious metals. In addition to the flux, lead is added as a collector. The sample is then heated in a furnace where it fuses and separates from the collector material as a button, which contains the precious minerals. Okay, later I'll show you one video how this fire assay method is conducting to extract the gold, silver, and platinum group metals. Okay. Then precious metal extraction. Once the button is separated from the gangue, the precious metals are extracted from the collector through process called cupellation. Once the button has cooled, it is separated from the slag and cupelled. When the lead is used as a collector, that lead oxidizes and is absorbed into the cupel, leaving a precious metal bead. The bead is then dissolved in aquaresia for analysis. For analysis, we can use atomic absorption spectrometry techniques like ICP-MS, inductively coupled mass spectrometry, or inductively coupled ICP-OES, optical emission spectrophotometric methods. Okay. Then gold alloys. Despite of gold's good characteristics or desirable properties, it does have one significant drawback. As gold also has one significant drawback, that is its softness. This means it wears out easily, it gets scratched easily because of that softness. However, mixing gold with other metals creates gold alloys that are stronger, more durable, and better suited for jewelry use. Okay, whatever the jewels we are using now, they are not made up of pure gold, they are made up of alloys with gold. Okay, so metals commonly allied with gold for jewelry purposes include silver, copper, nickel, iron, zinc, tin, manganese, cadmium, and titanium. I think all of you heard about cadmium gold. Okay, so cadmium gold, that is means cadmium mixed with gold, or cadmium is used for joining or soldering. That is called cadmium. Okay, 92% gold and 8% cadmium. Similar way, we are mixing copper, nickel, iron, silver, tin, manganese, and titanium. Okay. Then comes to hallmarking. I think all of you heard about hallmarking. Nowadays, everyone will wish to take the hallmarking gold only. What is this hallmarking? The need for alloying of gold also makes public extremely vulnerable to excessive adulteration, because jewelry person can make a gold 80%, 90%, 10%, 20%. He may add whichever the ratio, no, he can add. In order to avoid that adulteration, one hallmarking process has processed. Okay, so detection of are thus official marks used in purity or fineness of precious metal articles. In India, at present, two precious metals, namely gold and silver, have been brought under the purview of hallmarking. Then why hallmarking India? I told you, in order to okay, in order to avoid the adulteration, like in order to check the purity or fineness of gold, Government of India took cognizance of the need for protecting consumers. A mandate was therefore given to RBI, Reserve Bank of India, Standing Committee on Gold and Precious Metals, to look into the issues relating standardization of gold products and introduction of gold hallmarking in the country. These are the why hallmarking was started: to protect the consumer against irregular gold quality, develop export competitiveness, develop India as a leading gold market center in the world. Okay, the committee identify who will give you the hallmarking certificates. Okay, so committee identified Bureau of Indian Standards BIS in the year 2000 has the sole agency to operate the hallmarking scheme in India. The Indian standard on gold hallmarking is IS 1417-2016. It specifies the grades for hallmarking. First, only 3 grading was done. Now, 6 grading are going on: 14 carat, 18 carat, 20 carat, 22 carat, 23, and 24. What does it mean? 24 carat means full pure gold, means that is 24 carat means 1000. Finest number is 1000. 24 carat is 100% or 99.99 pure gold. 1000 fineness is. If it is 22 carat, 916.6, 916 we used to call. Okay, 22 carat means 22 among 24, 22 is gold and 2 is other metal alloy. Okay, so 20 carat means total 24, 20 is gold, 4 is other metal alloy. 18 similarly, 18 parts is gold and other remaining part is other alloy. Okay, pure gold which contains no other metals is termed as 24 karat gold. 50-50 alloy means, so 12 parts gold and 12 parts other alloy. Okay, 9 karat gold means approximately 37% pure gold to 24 karat gold. Then any of you observed someone wear earrings having some other color, someone having means wear gold bangles which is having different color, someone having bangles which is some whitish color or gold color, pink color, yellow color. Some color differs. Why color? Gold is already I have told the some yellowish red, but the color of gold changes when alloyed. Pure gold is one single color, but it color changes when alloyed. For example, mixing copper with gold creates a darker yellow color. Adding nickel plus zinc, copper, platinum, or manganese produces white gold. Typically, white gold does not contain silver, which softens gold and gives it a green tinge. Okay. So other gold alloy colors include: white means I have told 10% to 20% nickel plus copper, tin, sometimes platinum or manganese. Green means silver, sometimes cadmium and zinc. Red or pink means it is allied with copper. Yellow color means it is allied with silver and copper. Blue color means it is allied with iron. Okay. These are all the characteristics of the gold. Then comes to silver. Silver is a soft and lustrous metal that is grouped in the category of noble metals. Its brilliant white color, same malleability, and resistance to atmospheric oxidation have enhanced its value as a highly desired precious metal which is used in many industrial applications. When it comes to its resources, world view, Mexico, Peru, China, Poland, Russia, Australia, Chile, Bolivia, Kazakhstan are the main producers of silver. When it comes to India, there are no native silver deposits except the small and unique Bharat deposit in Rajasthan. In HZML in Karnataka also we are producing silver, but that is as a byproduct. But as a primary deposit, no deposits in Karnataka. Okay, so it occurs generally with lead, zinc, copper, especially their sulfide ores and gold ore, and is extracted as a byproduct from electrolysis or chemical methods. It was usually extracted by melting silver bearing lead ore. Okay, so ore containing argentiferous galena. Then what are the uses of this silver? Apart from its monetary and decorative purpose, silver is known to have the highest electrical conductivity amongst all metals and enhances its potential in modern age applications. Okay, namely for printed electric circuits, coating for electronic conductors, and in alloys of gold and copper for electrical contacts. And silver also have found many new uses today, these including photography, batteries of your mobiles, auto glass defogger, and magnetic strips. Okay, then tarnish. These noble metals have some drawback. I told you this gold has some softness is itself its drawback. Like that, most notably, silver tarnishes. I think if you observe in your silver articles in your home, slightly some black color. Okay, the term tarnish denotes a layer of corrosion that forms over some metals, including silver, when they undergo chemical reactions. The chemical reaction that causes silver to tarnish requires a compound called hydrogen sulfide. Since this compound can occur in out air, silver items left out exposed will tend to tarnish over time. Okay. Storing silver items in a protective pouches or containers will reduce the amount of tarnish. Then similar way as gold, we are getting the certificates, BIS hallmark certificate. Silver is also we can check the purity of fineness of 990, 970, 925, 900. It is the fineness number. Okay, so someone will call German silver. We have German silver idols in our home. Is it a true silver? No. These are the non-silver jewelry metals with silver names. Okay. The alloys known as nickel silver or German silver, for example, contain nickel, zinc, and other metals. Although they look like silver, hence the name, they don't actually contain any silver. Okay. These are the silver sources. What are the silver sources means? Silver bearing ore typically contains very little silver. I told you this silver as a byproduct of other gold ores, some platinum bearing ores. Okay, so with much higher percentages of copper and lead. Specific minerals includes argentite, chalcopyrite, polybasite, and prostite. Silver mainly occurs as a contaminant in chalcopyrite and galena, important ores of copper and lead respectively. Okay, then how these silver ore will get processed? Okay, once removed from the mine, the ore removed from the mine, silver containing ore is crushed into a small pieces, then small pieces into a small fine powder using ball mill method or vibratory cup mill to expose individual grains into chemical processing. Okay, so as a byproduct of mining of lead and copper, silver ores are often purified by froth flotation technique. After froth flotation, silver is extracted by a cyanide process akin to a technology used for gold extraction. In a similar way, as gold extraction, silver extraction will also takes place. Okay. Then come to platinum group metals. Okay. These platinum group metals is a family comprised of 6 metals: platinum, palladium, rhodium, iridium, osmium, and ruthenium. Okay. These have similar physical and chemical properties and tend to occur together in a same mineral deposits. The elements ruthenium, rhodium, palladium. These 6 elements again can be grouped into two. Ruthenium, rhodium, palladium are lighter elements, while the other three specific gravity elements, osmium, iridium, platinum, are heavier than gold. But within the range of these specific gravities are 21 to, it varies from 21 to 21.5. Okay. Then where are these platinum reserves? Platinum group metals. Okay, this platinum is an extremely rare metal occurring at a concentration of only 0.005 ppm in Earth's crust. ppm, parts per million, 0.005. It's the rarest metal. Okay, so by state, Odisha alone accounts for 90% of country's reserve in compared to India. These by state, Odisha alone accounts for 90% of country's resources of platinum group elements, followed by Karnataka and Uttar Pradesh with negligible amount. Baula Nausahi, a 3 kilometer long belt, 170 kilometer northeast of Bhubaneswar, Odisha, is the only proven platinum group metals deposit in the country. Then how these platinum group metals ore are processing. It's an overview. First, same ore is crushing, milling, and by gravity separation, it has to separate by flotation technique, then smelting, converting, refining, and analysis and determination by using analytical instruments using ICP-OES, means inductively coupled plasma mass spectrometric units, or inductively ICP-OES instruments. Okay, so first wet chemical analysis, then comes to fire assay method, then comes to analytical instrumental methods. Then what are the uses of these platinum group metals? Currently, more than half of platinum and palladium mineral goes into making catalytic converters in automobiles. Automobiles that run on diesel predominantly use platinum for catalytic conversion. Then platinum cured silicones are used to coat and protect the automotive airbags from the explosive system. When any accidents happen, the airbags contain an initiator sensor which uses a fine platinum wire coated with an explosive material to facilitate release of the airbag. Okay? The chemical inertness and refractory properties of these metals are conducive for their applications in electrical, electronics, dental, medical fields, and in the glass industry. These metals are also used as catalysts in various chemical processes, namely in organic synthesis, in hydrogenation. Especially, all of you read the hydrogenation by using the platinum as a catalyst, like that. Dehydrogenation and isomerization, production of nitric acid, the raw material for the manufacture of fertilizers, explosives, polymers, and fabrication of laboratory equipments, laboratory crucibles by using this platinum metal. Because why these platinum group metals are used means the non-corrosive and non-allergic properties of platinum find varied applications in medical field. Platinum's excellent compatibility with living tissue unaffected by oxidizing reaction of blood enables its utility in pacemakers by using platinum metal. Okay, the primary usage of these platinum group metals is in chemotherapy for the treatment of cancer. It has the ability to prevent the division of certain living cells. Cancer means abrupt division of cells. Okay, so these avoids the or prevents the division of certain living cells, a remarkable characteristic which finds profound application in the treatment of cancer. Besides, platinum iridium alloys are extensively used in prosthetics and biomedical devices. Okay. Then platinum's excellent conductivity lends itself for use in electrodes of phosphoric acid fuel cells for generating electricity. Another significant use of platinum and its alloys in cast and wrought form is in jewelry. Platinum and iridium alloys find major application in making crucibles for growing crystals and to fuse the mineral samples. Minerals samples are in the rock samples are in the solid form, rock form. We have to grind it to small, like the size of talcum powder. Then we have to brought into a liquid form. In order to bring the liquid form, these crucibles, platinum crucibles, are used to fuse the solid mineral samples to a liquid slag. Okay. Then let's discuss about one by one. Ruthenium. Ruthenium is named after Ruthenia, an old Latin name for Russia. This rare metal is found in the mineral pentandite and its pure form is commonly extracted from this ore. The compound called ruthenium dioxide is used in several components in electronic circuits, including resistors and microchips for computers and other digital devices. Okay? So adding a small amount of ruthenium makes softer metals such as platinum and palladium much tougher. Moving parts in devices such as switches benefit from this property. This is the Swiss Tech Convention Center in Switzerland. Okay, these are the low-cost solar panels are made using the ruthenium. This is the Swiss Tech Convention Center in Switzerland. These solar panels are made using the ruthenium. Then come to rhodium. The rosy red color of one of its compounds inspired the name rhodium. The Greek word rhodon means rose colored. Rhodium is unreactive and does not form compounds easily. It's a rare metal. Most of the pure form is extracted when platinum is mined. Pure rhodium is hard and is used to toughen precious jewelry, mirrors, and optical devices such as microscopes. Okay, this is the rhodium plating, rhodium polished jewelry. This is without rhodium plating. Okay, this rhodium plating prevents the jewelry from losing its shine. Here it shines, here no shine. Okay, then this is the rhodium alloy reflector provides a bright light. In the lights, we are using the rhodium alloy reflector. It provides a bright light. Okay. Then comes to palladium. Palladium is a rare precious metal. It is 10 times rarer than silver and twice as rare as gold. Like these metals, palladium has a shiny surface and does not corrode easily. Palladium is found pure in nature, but it also has a few rare materials such as bragite. Of its many applications, the element's main use is in catalytic converters, which are devices used in vehicles to convert poisonous exhaust gases into less harmful ones. The compound palladium chloride is used in carbon monoxide detectors. Okay, because the element is precious, it is used to make commemorative coins in some countries. Palladium is allied with steel to make it more resistant to corrosion. These alloys are used to make surgical tools like scissors, knives, okay, and expensive musical instruments such as some flutes. Then palladium is often mixed with gold to form an alloy called white gold, which is used in jewelry. Some fountain pens have nibs decorated with palladium, and the element is used in glucometer test strips so that patients can check the level of glucose in their blood. Okay, then comes to osmium. Osmium is the densest of all naturally occurring elements. The rare element is found in the ore osmiridium. The red osmium oxide stains cells so they can be seen clearly under the powerful microscope, while a black oxide powder allows fingerprints to be revealed in crime investigations. A hard osmium alloy is used in fountain pen nibs. The nib of these pen moves smoothly because of its hardly osmium alloy. See here, this is nib is made up of osmium. The nib of this pen moves smoothly because of its hardly osmium alloy. Then comes to iridium. Iridium is the rarest natural element on Earth. There is one iridium atom out of every billion atoms in Earth's rock. This dense metal can be found in its pure form in nature as well as in other common ores that contain nickel and copper. The applications of this element include coating the mirror of NASA's Chandra X-ray Observatory on an Earth orbiting telescope that studies X-rays from distinct stars. Okay, this is the Chandra X-rays Observatory. This telescope is used to study the X-ray from objects in space. This door protects the equipment from sun's glare. The iridium coating on the mirror is only a few atoms thick. It protects the instrument from the sun's glare. And iridium is most durable and than platinum and copper and is therefore preferred over these metals are used in spark plugs. Iridium is also mixed with osmium to make an alloy called osmiridium, which is used in compasses and put in nibs for some fountain pens to make them hardly. Okay, these are the few things about noble metals. Now I'll share one video how by using fire as a method these gold, platinum group metals and silver can be extracted.
This video will give examples of careers in precious metals using statistical analysis.
Not visible. Supriya, can you share that video?
I'll
Is
try
it possible?
1 minute.
Okay.
Physics, analytical chemistry, chemical engineering, metallurgical engineering, and others. There are over 200 analytical techniques used to determine precious metals.
One minute, ma'am. I'm trying.
Okay.
In between, if anybody having question, you can ask, ma'am. I'll just unmute. Okay. If any questions, you can.
Now, Deepa madam has to stop screen sharing probably for you too.
Okay. I've stopped.
If any questions, you can ask. I'll just trying to open that link.
Thank you for the very good talk, madam. Somewhere they also use this cadmium with gold,
Yes.
and that is also assessed how much cadmium, etc. Right? Why is that done? And yeah.
Cadmium means gold mixed with cadmium. That contains 92% gold and 8% cadmium. This cadmium is mainly used for soldering. That is called cadmium soldered jewelry is known as cadmium jewelry. But for few people, cadmium having some skin allergy. That's why nowadays it is not preferred, much preferred, but can use.
Any more? Okay.
Ma'am, to check original or duplicate of platinum, how can we measure?
To check.
Ma'am, to check platinum, it is original or duplicate. How can?
Okay, purity, how it can be checked, like gold and silver, the purity. But this, like BAS methods have not established, but platinum can be checked by analytical instrument methods like XRF, X-ray fluorescence instrument, fluorescence spectrophotometer instrument, like I told you, ICP-MS, ICP-OES, some instrumental methods by using that, okay, platinum is original or not, can be checked.
Yes, ma'am.
Yeah, in case you have heard, uh, mm, all of you, if you have heard Shyama's talk, she talked about um, how we do atomic studies on the moon, right? From remote sensing. Similar instrument can be used for checking metals in the lab. X-ray instruments.
Okay, I'm sharing. Okay, I'm sharing video. Ma'am, just check this one.
Okay.
Screen is visible, ma'am.
Yeah.
Shall I play it?
Yes.
Are you able to hear,
Yeah.
ma'am?
Please watch.
Are you able to
Voice
hear,
is
ma'am?
not
Okay.
only video. Audio is not.
Ma'am, you
Please.
can narrate with that video, no?
Not.
Can you?
Okay. Okay. So, Priya, is it possible to go to settings?
Okay.
You
1 minute.
switch on the transcript.
Where, ma'am? Go to settings.
Settings, no?
Hmm.
Go to settings.
Hmm.
You on the transcript in that video.
No, ma'am. I'm not getting here. Just you go through it, ma'am.
Wait.
1 minute. I'll trying.
Physical analysis, physics, analytical.
Simultaneously, we can play it now, ma'am. Your audio is audible to us.
Okay.
Just see, ma'am. I'm just
Briefly,
starting.
we could hear the audio, Supriya.
Chemistry, chemical engineering, metallurgical
Yeah. Now
engineering,
audible?
and others.
Yes.
There are over 200 analytical techniques used to determine precious metal concentrations in material.
Supriya?
Methods range from classical wet chemistry to fire assay and instrumental analysis. Materials. Methods range from classical wet chemistry to fire assay assay is the standard and classical analysis technique used in determining the precious metal content of silver and gold containing ore and secondary concentrates. Although it is more time-consuming and elaborate than instrumental use, fire assay is a well-established technology that has been around for thousands of years. The term fire assay dates back to ancient times where fire was used to create the high temperatures needed for the metal reaction occurring in this method. Fire fueled the furnaces, which over time have been replaced by gas-fired furnaces, and eventually the high-temperature electric lab furnaces used today. The origins of fire assay techniques have been traced to ancient Asia Minor after the discovery of the manufacturing of lead from lead ore. Very pure silver was produced from lead. Detailed written records of the art of assaying minerals and metals appeared in De Re Metallica, published in 1556. Fire assays are still routinely performed on gold and silver ore samples. It is also used for the analysis of secondary or scrap materials, as well as for separating and concentrating platinum group metals, with the exception of osmium and ruthenium. The fire assay process can be broken down and explained in 3 big steps: preparation, collection, separation. Sample preparation is generally first done by grinding or milling samples into a fine powder. This is so the sample can be thoroughly mixed with dry powder chemicals used in the next step. Initial samples are sometimes evaluated by another method, such as XRF, to provide a rough indication of the composition to help determine the amount of reacting chemicals to add. The precisely weighed sample and dry reactant are then thoroughly mixed together. The second step is called crucible fusion, as the mixture is heated in a crucible, which is a ceramic or metal container used to heat contained samples at very high temperatures. The mixture is heated until all the powders fuse together into a glass-like slag, where a complex series of reactions then occur to collect all of the precious metal in an alloy. The classic example is fusion, where lead oxides and is reduced to fine droplets. The precious metals absorb into these droplets as they sink through the slag and collect at the bottom of the crucible as a precious metal lead alloy. The chemicals in the fusion process each have a specific function. Activity and viscosity are the important chemical and physical properties of the slag. An example of a typical recipe or fire assay fusion charge for quartz-based ore is shown here. Once the reaction is complete, the contents are poured into a mold or breakable crucible, allowed to cool, then the metal alloy is removed from the slag. The lead served to collect the precious metals. Metallic samples can be processed by fire assay using lead rather than lead oxide. The samples are wrapped in lead foil to provide the lead factor. Fillers sometimes also added to help completely dissolve the sample into the lead alloy for cupellation. Platinum group metals are much more difficult to analyze in fire assay. Other metals or metal compounds such as copper or nickel sulfide are sometimes added as collectors when platinum group metals are present. The third step in the fire assay process is to separate the precious metals from the collector. The separation step is called cupellation, as the precious metals are separated from the collector in a cupel. A cupel is a porous ceramic vessel, which is typically a shallow cup made of porous bone ash or calcium phosphate. When lead fusion is used, the lead alloy B is placed into the cupel and heated in air to 850 C, 1562 Fahrenheit. As the alloy melts, the lead is oxidized along the surface of the small pool of molten metal. The lead oxide then absorbs into the cupel. This continues until all the lead is drawn out, leaving a small bead containing only precious metals to complete the separation from the collector. The bead is then weighed and analyzed further for precious metal content using an instrumental analysis technique such as ICP AES. When silver is present in a gold-bearing sample, the bead can be further analyzed by parting, or dissolving away the silver content in nitric acid solution, leaving the gold. Concentrations can then be calculated by the weight ratios. Low concentration samples will produce very small beads, so silver is sometimes added in the fire assay process as a way of obtaining a larger bead, which improves accuracy of results. As with instrumental analysis, there are instances where the presence of other metals interferes with results, so other analytical methods must be used. Fire assay is the workhorse of precision analysis for precious metals. It is a highly accurate analytical method used for both primary and secondary sources of precious metals. Wet chemistry, or gravimetric analysis, will be reviewed in our next video. The International Precious Metals Institute promotes the education and advancement of precious metals technology and business. IPMI is an international association of companies committed to providing technical resources and educational materials, including a series of videos presenting examples of precious metal applications and a variety.
Okay.
ನೋಡಿದ್ರಲ್ವಾ ವಿಡಿಯೋ? ಸೊ ಈ
Yes.
ವಿಡಿಯೋದಲ್ಲಿ ಏನಿಲ್ಲ, ಸೊ ನಾವು ಯಾವುದೇ ಒಂದು ಮಿನರಲ್ ಲೈಕ್ ಪ್ಲಾಟಿನಂ ಗ್ರೂಪ್ ಮೆಟಲ್ಸ್ ಆಗ್ಬೋದು, ಗೋಲ್ಡ್ ಆಗ್ಬೋದು, ಸಿಲ್ವರ್ ಆಗ್ಬೋದು. ಫಸ್ಟ್ ನಾವು ಓರ್ ಅನ್ನ ತಗೊಂಡು ಓರ್ ಅನ್ನ ಕ್ರಶ್ ಮಾಡ್ತೀವಿ. ಲೈಕ್ ಈಗ ಅದು ರಾಕ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಲ್ವಾ, ಸೊ ಸ್ಮಾಲ್ ಪೀಸಸ್ ಆಗಿ ಕ್ರಶ್ ಮಾಡ್ತೀವಿ. ಸೊ ಕ್ರಶ್ ಮಾಡಿದ್ಮೇಲೆ ಏನ್ ಮಾಡ್ತೀವಿ, ಅದನ್ನ ಪೌಡರಿಂಗ್ ಮಾಡ್ತೀವಿ. ಲೈಕ್ ಬೈ ಯೂಸಿಂಗ್ ವೈಬ್ರೇಟರಿ ಕಪ್ ಮಿಲ್ ಆರ್ ಬಾಲ್ ಮಿಲ್ ಅನ್ನೋ ಅಂತ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಅಲ್ಲಿ ಚೆನ್ನಾಗಿ ಪುಡಿ ಮಾಡ್ತೀವಿ. ಯಾವ ತರ ಪುಡಿ ಆಗ್ಬೇಕು, ಲೈಕ್ ಈಗ ನಾವು ಫೇಸಿಗೆ ಹಚ್ಕೊಳ್ಳುವಂತ ಟಾಲ್ಕಮ್ ಪೌಡರ್ ಅಷ್ಟು ನೈಸ್ ಆಗ್ಬೇಕು. ಅಷ್ಟು ಪುಡಿ ಮಾಡದ್ಮೇಲೆ ಅದನ್ನ ಲೈಕ್ ಫ್ಲಕ್ಸಿಂಗ್ ಏಜೆಂಟ್ ಕೆಮಿಕಲ್ ವಿ ಹ್ಯಾವ್ ಆಡ್. ಓಕೆ, ಸೊ ಅದನ್ನ ಆಡ್ ಮಾಡ್ಬಿಟ್ಟು ಹೈ ಟೆಂಪರೇಚರ್ 800 to 900 to 950 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ನಲ್ಲಿ ಫರ್ನೇಸ್ ಒಳಗಡೆ ಸೆರಾಮಿಕ್ ಕ್ಯುಪೆಲ್ ಅಂತ ಏನ್ ಹೇಳ್ತೀವಿ, ಕ್ರುಸಿಬಲ್ ಅಂತ ಏನ್ ಹೇಳ್ತೀವಿ, ಸೊ ಅದರಲ್ಲಿ ನಾವು ಕರಗಿಸ್ತೀವಿ. ಸೊ ಕರಗಿಸಿ ಆದ್ಮೇಲೆ ಅದು ನೀರ್ ತರ ಸ್ಲಾಗ್ ಆಗತ್ತೆ. ಸೊ ಅದಾದ್ಮೇಲೆ ಏನ್ ಮಾಡ್ತೀವಿ, ಅದಕ್ಕೆ ಲೆಡ್ ಆಡ್ ಮಾಡ್ತೀವಿ. ಸೊ ಲೆಡ್ ಆಡ್ ಮಾಡಿದ್ಮೇಲೆ ಏನಾಗುತ್ತೆ, ಎಲ್ಲಾ ಅದ್ರಲ್ಲಿರುವಂತ ಇಂಪ್ಯೂರಿಟೀಸ್ ಎಲ್ಲ ಲೆಡ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗ್ಬಿಟ್ಟು ಸೊ ಲೆಡ್ ಆಕ್ಸೈಡ್ ಫ್ಯೂಮ್ಸ್ ಬರುತ್ತೆ. ಪ್ಯೂರ್ ಮೆಟಲ್ ಲೈಕ್ ಪ್ಲಾಟಿನಂ ಇರ್ಬೋದು, ಗೋಲ್ಡ್ ಇರ್ಬೋದು, ಅಥವಾ ಸಿಲ್ವರ್ ಇರ್ಬೋದು. ಲೈಕ್ ಬೀಡ್ ಸಣ್ಣದೊಂದು ಬಟನ್ ತರ ಬಂತು ನೋಡಿ, ಅದು ನಿಮ್ಮ ಓರ್, ಪ್ಯೂರ್ ಆಗಿ ಬರುವಂತ ಓರ್. ಅದನ್ನ ನಾವು ಎಷ್ಟಿದೆ ಅದು ಓರು, ಅದನ್ನ ಡೆಟರ್ಮೈನ್ ಮಾಡ್ಬೇಕಲ್ವಾ. ಸೊ ಅದನ್ನ ಡೆಟರ್ಮೈನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆ ಓರನ್ನ ಮತ್ತೆ ಆಸಿಡ್ ಒಳಗಡೆ ಅಥವಾ ಅಕ್ವರೀಸಿಯಾದೊಳಗಡೆ ಕರಗಿಸ್ಕೊಂಡು ಅದನ್ನ ಬೈ ಯೂಸಿಂಗ್ ICP-OES ಆರ್ XRF, ICP-MS ನಂತಹ ವೆಲ್ ಸಫಾಸ್ಟಿಕೇಟೆಡ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ ಗಳಿಗೆ ಫೀಡ್ ಮಾಡ್ಬಿಟ್ಟು ಸೊ ಅದರದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅನ್ನ ನೋನ್ ಗೋಲ್ಡ್, ನೋನ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗೋಲ್ಡ್ ಜೊತೆ ಕಂಪೇರ್ ಮಾಡಿ ಸೊ ಅದರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅನ್ನ ಡಿಟರ್ಮೈನ್ ಮಾಡ್ತೀವಿ. ದಿಸ್ ಇಸ್ ಒನ್ ಆಫ್ ದಿ ಮೆಥಡ್, ಫೈರ್ ಅಸೆ ಟೆಕ್ನಿಕ್. ಇದರಲ್ಲಿ ತುಂಬಾ ಹೈ ಟೆಂಪರೇಚರ್ ಫರ್ನೇಸ್ ಗಳನ್ನ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ದಿಸ್ ಇಸ್ ದಿ ಮೆಥಡ್ ಫಾರ್ ದಿ ಎಕ್ಸ್ಟ್ರಾಕ್ಷನ್ ಫ್ರಮ್ ದ ಮೆಟಲ್ಸ್ ಫ್ರಮ್ ದಿ ಅರ್ತ್. ವಿ ಆರ್ ಮೀನ್ಸ್ came to the extent of jewelry or ornaments. This is the today's topic.
Thank you, ma'am. Any questions from audience?
No questions, sir?
It's a clear presentation, ma'am. It was great presentation. Thank you for answering our questions. We hope everybody enjoy this presentation and learn more. Thank you, Deepa ma'am, for your time and your knowledge for sharing in Creactive. Thank you very much.
Thank you, Srinath sir and Supriyanka and all the Creactive team for this great opportunity and all the audience. Okay.